Welcome everybody to today's Forecast Decision Training Division GOES 16 Applications webinar. Today we're pleased to have two presenters. We have Greg Gilliott from the CWSU at Denver ARTC, located in Longmont, Colorado. And we also have Rebecca Mazer from WFO Cheyenne.
My name's Greg Gilliott, Denver Center Weather, located in Longmont. I just wanted to send a quick thanks to Dana Ed for inviting me, allowing to speak briefly. It's also a pleasure to be here with all of you and presenting as well with Becca. So I appreciate that. So again, thanks for allowing me to speak briefly on an interesting mountain wave case here. It took place back in early March. One in which the use of the new GOES 16 water vapor imagery allowed me to make some important near-term decision support decisions with a lot of precision as well, I might add. So I wanted to get started. Quick overview here. This event took place on March 9th in the morning, roughly about 15:45 Z, and it ended about 18 Z. On the morning of March 9th, 2017, severe turbulence reported west of DIA during the late morning hours to noon. It was northwest as well, so west around to northwest. That is important there when it comes to the progression here. And again, as I mentioned, GOES 16 water vapor imagery clearly showed the wave, which is really interesting to see. And again, this case shows how that imagery was used to decide to actually keep one arrival gate open, as well as to reopen the west departure gates. I'll get into that stuff here in just a moment. I believe that's on the next slide, as a matter of fact. But again, importantly, showing how it can show how it ends the event in real time. So, real quickly, I'm not sure how many of you are familiar with CWSU and airport operations in general. This is an overlay from my AWIPS of a rough outline of Denver's terminal radar and control approach map. Most of this you really don't need to know, except you do need to know the generalities that, like most major airports, DIA operates on an 8-point cardinal system. So basically, the arrivals will come through the northwest, northeast, southeast, and southwest. And in this particular case, the Rams-Thompson northwest gates. I'll just refer to those as the northwest gates through the rest of the talk here. And on the west side, your departures are going to go out of the 4 cardinal directions, in this case, northeast, south, and west. So, and again, in this case, the important departure gates were the west departure gates. When it comes to each cardinal direction, in this case, the west departure gates, they're actually made up of 4 specific routes. So there are 4 west departure gates heading out from the west of Denver International Airport. Next slide, please. Okay, real quickly, I don't think I need to really go into the formation of wave and all that, so I'll just skip through to the morning. And I apologize, I didn't realize this was going to be used when I was actually taking all these screenshots, so I don't have many accompanying slides to set the stage or anything like that, so I'm going to have to do that verbally. On the morning of the 9th, as with the case of a lot of meteorological phenomena, it wasn't cut and dry in terms of the severity of wave we were going to have, or even if we were going to have a wave across northern Colorado that morning. It was one of those cases where, for every reason I could find that we should have a good amount of wave, I could probably find a reason the wave probably wouldn't develop to that great of an extent, at least. We had a jet streak that morning around 12Z, progressing quickly eastward across the southern portion of Idaho. And that was supposed to rapidly move eastward across southern Wyoming by about 18 to 19 Z, give or take, in terms of the nose of the jet, that is. Most of the time, the most wave and turbulence activity can be expected along the axis of the jet and about perhaps about 100 to maybe 200 miles to the south. So that's what the positioning was good. There were some other indications, again, whereas we thought maybe this may not be that big of a wave event after all. So fast forward to 15Z, Received very few wave reports. In fact, from my recollection, I'm not even sure if we even had one at 15Z. And I began to wonder, well, maybe we're not going to have much wave after all. But between 1545 and about 16Z, suddenly about 5 or 6 severe mountain wave reports in a row came in rapidly over to the northwest of Denver, around the Laramie area, and points to the west of Denver as well. I don't have the control, but if you're not familiar with what we're looking at here geographically, the small square right almost dead center of the screen there, that's technically the outside of the outline of Denver, but that northeast portion of it is essentially the Denver airport. Of course, you have Colorado, northeast Colorado. To the north there, southeast Wyoming. And, of course, got the far southwestern portion of the Nebraska Panhandle off to our northeast, as well as northwest Kansas directly to our east. Thanks for the cursor there, Dan. I appreciate that. So, between about 16 and 17Z, we had numerous severe, I think we even had one extreme mountain wave report between about 16 and 17Z, such that there is consideration to shutting down the northwest arrival gates. And we had to go ahead and toggle one more, I believe. Go ahead and, yeah, there you go. So, let's see, I can't see the time stamp on this, but I believe this is around 1715, 1720, if I'm not mistaken.
1707.
Okay, 1707. So I went ahead and put a rectangle around the deep red there, immediately west of the Denver. By this point, our 2 of the 4 west departure gates had been closed off to traffic due to severe mountain wave and turbulence. And there was already consideration to closing off the northwest arrival gates by this point as well. So go ahead and you can toggle through real quickly for about 3 or 4 frames. And as you'll notice, particularly the southeast Wyoming portion of the wave, up there just to the east of the Snowies, and into northwest Larimer County here in Colorado, that portion of the wave is noticeably starting to break down. And again, this was the part that was really neat for me. I was able to tell these guys as they were trying to determine what to do with Northwest Gates. I was able to tell them. I turned around to the supervisor of the TMU group here. Again, this is my first time using this imagery, and I said, I think the wave is showing signs of weakening or dissipating. So, for what it's worth, they kept the gates open. If you wanted to go ahead and just toggle through. The wave continues to break down across the north. And if you train your eye really closely on northeast Colorado, you can see the passage of the shortwave trough. That normally will disperse the worst, at least, of a wave with the cessation of warm advection out ahead of it, cold air advection behind it. So as you toggle through, you can see the wave clearly breaking down. And again, as I have noted up there, by 1815, evident most of the wave structure and amplification is breaking down, with areas southwest of Denver soon to follow. Severe mountain wave and turbulence reports sharply went away by 18Z. It was really interesting to watch that all play out in real time. And all west departure routes reopened as well. Go ahead and forward. Let's see. I already have 112. Dan, do you want to truncate most of the remainder of this portion of it, or you want to keep going?
Would you like to just briefly look at a couple of these with the other water vapor channels?
Sure. It's entirely up to you guys. I don't want to step on Becca's time as well. So.
Okay, maybe we'll just do a couple. So this was the first one.
Okay.
And so here's what you showed, and then this is a different projection of the same.
Hey Ed, can you move closer to the mic?
Yeah. So this is a different projection of this image from AWIPS. And then we'll look at a couple of the other bands. So Greg, you said you also looked at some of the other bands. What were your general impressions?
did, yeah, and we're about to go through those real quickly. The signature does show up in the high and low water vapor channels, but for whatever reason, the mid-level channel really stands out in terms of amplification. One thing I didn't mention that on this particular day, sometimes, as you guys are possibly well aware of, you have a notable mountain wave cloud that's clearly visible, and sometimes the cessation of the mountain wave cloud in itself can signal the end of a wave. But in this particular day, pretty well clear skies across the area, so visible satellite was not of any use. So yeah, it was a really good case of being able to use the mid-level water vapor imagery. The low-level water vapor imagery is pretty interesting in terms of watching the short wave go by, but you really can't see the evident wave structure as well, in my opinion, in terms of the color curves and stuff like that. So.
Maybe we'll skip the loops, Greg, and then we'll go to the takeaways here. So.
Sure. Okay. So yeah, just to wrap things up, in this particular case, and cases I've had a few from this point on, particularly mid-level water vapor imagery allowed for the monitoring of real-time in terms of the formation, evolution of a mountain wave case east of the divide here in north-central Colorado. The mid-level water vapor imagery nicely showed the mountain lead wave intensification, which was coincident with the significant increase in severe turbulence, mountain wave reports, etc. The advantages, numerous. Increased spatial, temporal resolution, of course, of the imagery, and just simply the fact that we've got 3 channels versus the 1. Let's see, the imagery again helping in deciding to keep our northwest gates open during that time frame, which is a big deal in terms of added fuel for numbers of planes, connections, things of that nature. So it's not a minor thing to close down gates and have to send those planes to a different arrival gate. Again, the imagery was really important in showing the wave becoming less organized after roughly 90 minutes or so, allowing the west departure gates to be reopened. And again, water vapor imagery of the channels. For this case, it certainly looks like the 6.2 mid-level channel worked. 6.9 mid-level channel worked well. But the upper level one showed it pretty well as well, just simply due to better spatial resolution. Not quite as much in the low levels. And again, one question is, does this vary with different cases? I've been able to play around with a few of these waves since I took those screenshots. I have noticed that again, they do show up nicely on all 3 channels, but far and away the mid-level seems to be the best. I did take a look one day when we had a trapped set of waves going on, just essentially subsident waves in the lee of the mountains, and those on the mid-level channels really do not show up well, which is good. My point is, the mid-level channel seems to really be good at accentuating amplified mountain waves. Okay, go ahead and advance.
Okay, at this point, we'll take any questions or comments for Greg.
One question from AWC.
Yeah.
Do you recall about what altitude your mountain wave reports were coming in on?
They were pretty much all over the map. After a while, either we issued a CWA or you guys there issued a SIGMET and started rerouting, en route planes around. But at the beginning, I think we had pretty much every altitude from about 250 all the way up through 442, 430.
And what altitude are the planes typically at when they hit the arrival and departure gates?
It's different for each airport. For that particular gate and this particular airport, between about 17 and flight level 180.
Okay.
Hey, Bruce, this is Mike in Medford. Was that the case that you and I talked about, Mr. Entwistle?
I vaguely recall that conversation. It may have been.
Yeah, I think so. I had a question for Greg. Did you?
Sure.
Is this the case where there's publicity about the injured flight attendant
No.
One of the,
No, that was later in April, I believe. That was across southern Colorado. If it was the one that inevitably came out the other side and was, I believe, was heading to either Chicago or Boston. I can't remember now, but they made a divert to Denver to land.
going to Aspen?
To Aspen, huh?
Yeah.
Huh.
Anyway, the question I was going to ask about that one kind of applies to this one. Were you able to identify in particular specific waves and when severe turbulence reports came out? Like, were you able to put the position of the plane on any given, high-resolution indication of the mountain wave there, like the specific wave?
Right. No, the short answer is no. That's one of the things that I would love to do. Unfortunately, as you know, we're pretty well out of wave season at this point, so some of this stuff may have to wait until the fall and the winter. But it's one of the things that I would love to do in terms of continuing to study, the uses of mountain wave monitoring through these new water vapor channels that we have. But at the time, when I was taking these screenshots, I didn't even, in the beginning, it didn't dawn on me initially that, to have it up and running before the wave even started. If you recall, I mentioned that even at 15Z there was hardly anything there. And it just didn't occur to me to get that running, because it would really be interesting to try to capture the first signs of the lee side subsidence before the wave really gets ramped up vertically. But yeah, this was March 9th. I can't remember, exactly when we got GOES 16 data at the here in the FOs and here as well. But it wasn't long before March 9th, and so it just didn't occur to me. And there was a point there, somewhere around 1630Z, where I remember going through the training, and there was a specific section there on mountain waves, and I thought, let me hurry and pull this up and see how this looks. So I caught it mid-event. So I wasn't able to catch the ramp up, but I was able to catch the dissipation of it, which was, just shows, immense potential there in terms of trying to monitor in real time and keeping gates open and closing gates, stuff like that. So.
Yeah. Okay. All right. Thank you very much.
You bet.
Any other questions for Greg? Okay, we're going to move to our next presenter, who is Becca Mazer at the Cheyenne WFO. And I can see your screen, Becca.
All right. Let's go. All right, good afternoon, everybody. Thank you, first and foremost, Dan, for inviting me to speak today. I very much appreciate it. My name is Becca Mazer. I am a lead forecaster here at WFO Cheyenne. And today I'm going to talk about an example of a mountain wave that I viewed on GOES 16 early morning on March 3rd. And just to answer Greg's question, I think we had gotten GOES 16 data in our WFO in AWIPS on March 2nd. So this was my first look at GOES 16 data. And so I'm going to look at a mountain wave and how it correlated to strong wind gusts at the surface at one of our more wind-prone spots. First and foremost, we're going to look at a quick forecast overview from the night of March 2nd through morning of March 3rd. We were expecting moderate winds across the Cheyenne or CYS wind-prone areas overnight period as a moderate surface pressure gradient developed in advance of approaching shortwave that was coming down from the northwest. Also, we were expecting mountain wave activity to increase in advance of the shortwave, and we were thinking we were going to see some stronger wind gusts of 45 to 50 miles per hour at the surface, which may not seem all that strong to some folks. Certainly not super strong for southeast Wyoming, but it is. Once we start to get 50 mile an hour or plus, we start to see impacts to high-profile and light vehicles along the interstate, especially I-25 and I-80, which both run through the Cheyenne CWA. So our main forecast problem for the night was timing the onset of the stronger wind gusts due to the mountain wave activity in the wind-prone areas, again, along the major interstates and highways. And this is a common problem here that we have, where we can, forecast the general pattern and get an idea of we're going to see moderate to strong winds, but exactly when is the mountain wave going to develop, and are we going to see some of those strong winds at the surface? And so it's kind of one of our forecast problems here. Hopefully GOES 16 can help us with that in the future. So the one case we're going to look at, again, happened early morning, March 3rd. It happened roughly between 11 and 13Z. This image here shows the general location of the mountain wave downstream of the Laramie Range, which is this brown line here. We do have one higher peak in the area, which is Laramie Peak at just over 10,000 feet. And the general flow pattern was from the northwest to the southeast. We'll look at a loop here in a second of it. But this spot here, along I-25, it's Bordeaux Road exit, or we just call it Bordeaux in a lot of cases. LIDAT has an RWIS sensor here just because it is such a hot spot for strong winds in the wintertime season, and we get multiple blowovers of trucks and other light and high-profile vehicles in this particular area. So this is the main area that we're going to focus on, and this is the actual wave we're going to look at. You can see this is viewed on the mid-level water vapor channel, channel 9. You can see the ridge and then the trough, and then the ridge and trough as it goes downstream. So here's the loop that I promised of the channel 9 mid-level water vapor. So you can see the shortwave approaching from the northwest to the southeast. And initially you could see perhaps maybe this is the nose of the jet pushing through as the mountain wave really starts to develop and translate to the east-southeast. And as it approached Bordeaux, as we'll see in a second, winds went from relatively light for that specific location, and actually they were out of the northeast. They quickly switched to the northwest and ramped up very quickly, which is not uncommon for this specific area, hence one of our forecast problems. How do we time the onset of these stronger wind gusts? Because it is a major commerce problem. So again, I'll just let this loop a couple times. As the trough approached and then moved over the Bordeaux site, that's when we really started to see the winds increase. So this suggests perhaps that we can use GOES 16 water vapor to diagnose the onset of these stronger wind gusts and improve our DSS not only to commerce but also to LIDAT in general. We can get them on the phone and be like, hey, we figure the stronger gusts are going to occur at such and such time, because we often get that question from LIDAT folks. And we can also put it on social media and let our traffic customers be aware of this sort of situation. Before I move on to the next slide, I quickly wanted to point out in our other hotspot, Arlington, which is out in this area here near the Snowy Range, a similar pattern or a similar thing occurred where the mountain wave really started to ramp up. And as soon as the trough of the wave moved over the Arlington site, we saw strong wind gusts once again. So here's a close-up view of the winds. We'll start here at 3:30 a.m. or about 10:30 Zulu, and then time increases as you go up. So initially, winds here at the Bordeaux site were about 12, gusting to 18 miles an hour, again out of the northeast. And then as that mountain wave approached, you can see a quick speed increase as well as direction change. And then as the trough moved over the Bordeaux site, we started to get wind gusts of 50 to 50 miles an hour. So again, this is a common problem that we see here where the winds just accelerate significantly in a very short period of time, within 20, 30 minutes. And so perhaps GOES 16 water vapor imagery could help us to give our customers a better heads up ahead of the event. So I just wanted to give a quick comparison of the different water vapor channels. Similar to Greg's observation, at least for these deeper mountain waves, mid-level water vapor channel shows these waves better. The low level here in the upper right, and then the upper level water vapor, channel 8, in the bottom here. You can definitely see the wave on both channels. However, they're just not as defined. You can't see quite the movement of the trough, the ridge and the trough of the wave as well as you can in the mid-level water vapor channel. So I have a similar observation to what Greg was showing with this case. So some final thoughts. Again, hopefully in the future, GOES 16 can provide forecasters some guidance in determining the onset of stronger wind gusts at the surface resulting from mountain wave activity. There are obviously some negatives. You can't see these mountain waves if there's other clouds in the vicinity to obscure the view of the mountain wave. And oftentimes, mountain wave reflection at the surface could depend on a number of atmospheric features. So it may not be, one-to-one correlation, but perhaps in the future we can at least maybe hit one or two more events with better timing of these stronger wind gusts and to help out our commerce customers as well as LIDOT in general. I think with that, I'll take some questions. No questions. All right.
Oh, any questions or comments for Becca?
One question here from AWC. Have you tried the other mountain wave color curve with this example to see if it teases out, or at least your eyeballs can pick up the features a little bit better?
I have not actually. March, that event was basically the end of wind season for us, at least for me. I don't remember seeing many other mountain wave cases that I could play with other color curves. There were one or two, but we had so much cloud cover overhead I couldn't see the mountain waves. So unfortunately, no. As we ramp up into mountain wave season next year, I definitely will take a look at it.
It'd be interesting to see the comparison using the dry yellow curve.
Yeah, very much so.
Hey, Becca, this is Mark in Billings.
Hi.
I just wanted to, you might want to point out that we have a chat room with the Y Travel that we can communicate this sort of stuff with, just for a DSS thing to kind of tell them how we get the information to them.
Absolutely. Yeah, we have a special chat room for, as Mark mentioned, it's called Y Travel. We have our YDOT customers, some of our private sector transportation customers are all in that chat room. And yeah, that would be a great avenue to let our folks know, hey, we see this mountain wave activity developing. We could perhaps start seeing wind gusts of such and such miles per hour soon. And the Y Travel chat room was developed as part of the Pathfinder project, which is a collaboration between private and government travel forecasters and travel partners, I guess you could say, to just better serve our travel customers and make sure we're on the same page with forecasts and decisions and alerts in general. So we've been doing it a couple of years now, and it's been huge success, we think, in alerting our travel partners.
Hey, Becca, this is Julie. I'm a forecaster in Billings.
Hi.
Hi. I was looking at your page with the 3 different levels of water vapor, and I kind of like the one in the upper right, and I'm not sure which one we're supposed to like, To me, it just showed the most color variances and stuff, so which one would you recommend if you could go back to that slide?
I should have it up there right now.
Yes, there it is. Yeah.
Yeah.
I kind of like 10 and 10.
Yeah, upper right is the low-level water vapor, upper left is mid-level water vapor. And for me, I can see the development and movement of the wave itself a lot better in the mid-level water vapor, but maybe the low-level water vapor will work better for you or for other folks. And yeah, it'll be interesting to see if we can change the color curve and perhaps emphasize the wave a lot better on this low-level water vapor channel. I wish we could test that out now, but we're not in mountain wave season anymore, so at least
that's true.
We're out of it.
Okay.
Hey, this is Todd over here. One
the
really easy thing you can do in D2D any old time is just right-click, change color map, and change the max and min according to the situation. You can really bring out features that way.
Mm-hmm.
Like I do that now, and I can really see actually quite a bit of turbulence today from Colorado, especially up towards southern Montana. Just right-click and change color map and play with the max and min to really...
So it would be a matter of, finding a color scale or changing the max and min to whatever you think could really emphasize these waves. So perhaps maybe changing the color scale, the low-level water vapor will really show a better defined wave. That'll be interesting to see in the future.
Any other questions or comments for Becca?
Well, this is Todd again. I guess I got another question. Has there been has anybody looked into seeing what values of the water vapor from wave to wave, like what difference in values corresponds to a certain amount of turbulence or reflection at the surface? I don't know. It seems like you might be able to get some, correlation, hopefully, with turbulence or with surface wind compared to the values in the water vapor from wave to wave.
I haven't yet, just because this was one of the last cases that I saw regarding mountain wave activity. Again, the other cases that I noticed, I tried to see if we had any mountain wave activity on water vapor, but there was just too much cloud cover, so I couldn't actually see the wave. But that's definitely something I'll look into as we go into next season. Try to, maybe pick out some values of water vapor imagery from the ridge to the top, to the trough, and correlate that with wind speeds and see what we can find. If there's maybe some sort of algorithm we can come up with in the future, or just key in on those values and see what we can get.
That would be interesting. This is Greg from ZDV in terms of true turbulence and wave activity aloft and everything. And that would be pretty interesting to see how that would correlate, from in terms of flight altitude, what stratums to stay out of and stuff like that. Pretty interesting stuff.
Any more questions or comments for Becca? Okay, well, we want to thank our presenters, Greg and Becca, for the last time here, and also remind you, if you come across an interesting event and you'd like to present on one of these webinars in the future, just let myself know, Dan Bicus or Scott Lindstrom. And that's it. Have a great day.
Thanks, you guys.
Thanks, Dan.